You ever look at something really complex, maybe, I don't know, how your own body works, or even a big city, how it just sort of functions. And you get that feeling that things are working together, like there's some kind of purposeful organization going on.
Oh, yeah, absolutely. It's a very intuitive sense, that feeling of underlying coordination.
Well, here's the question that really got me thinking, and it's what we're diving into today. Can we actually measure that? Can we put a number on how well a system is, lining things up to hit a goal?
Hmm. Hmm.
Because if we could do that, well, that would change how we look at pretty much everything, wouldn't it?
It really would. And it's a tough one, right? Traditional science has struggled with this. I mean, we've got powerful tools, thermodynamics for energy and disorder, entropy,
Yeah.
information theory for data, but they don't really have the formal language, the math, to quantify how systems organize themselves to, well, persist and thrive.
To succeed.
It's exactly, to adapt,
Yeah.
to succeed against challenges. They tell us about decay, about randomness, but not so much about the, let's say, drive towards order or function.
Okay, and that brings us right to today's topic.
Hmm.
We're looking at something pretty new, a transdisciplinary science called Telic Engineering, or TE,
That's right.
proposed by Shahryar Ghiasi. And our goal here is really to unpack this framework. It's aiming to give us a rigorous predictive science of teleology, the study of purpose, but specifically in these complex adaptive systems.
Yeah, systems that learn and change.
And what's really wild is that TE suggests this functional coherence, this purposefulness.
Yeah.
It's not just some vague idea. It says it's an emergent property you can actually measure,
Quantifiable, yeah.
model it, maybe even engineer it.
Yeah.
So let's get into how that could possibly work. All right, let's start at the beginning. What are the really core foundational ideas that Telic Engineering is built on?
Okay, so at its heart, TE introduces a couple of really key principles. The first one is something called the Telic Conservation Law. Now, the way to think about this is, purposeful organization isn't just a state you achieve and it stays there. It's more like tending a garden. It needs constant effort.
Right, you have to keep weeding.
Exactly.
Sure.
It takes energy, takes information input to keep it vibrant, to keep it coherent. Otherwise, decay, disorganization, telic entropy takes over. So this law introduces a few key terms. There's coherence, which they label gamma. Gamma, that's your measure of alignment.
Gamma, okay.
Then there's telic entropy, hold lambda.
Yeah.
That's the opposite, the functional messiness, the drift away from the goal.
Tut it.
Adaptive potential, lambda. That's the system's ability to change and fix itself.
Lambda. Resilience.
Resilience, flexibility, yeah. And finally, coherence work, coordinatal.
Yeah.
That's the energy and info needed to maintain that coherence, to fight this subtle lambda. So the law basically says systems have to constantly do work just to maintain their functional purpose. It builds on ideas from thermodynamics, but it's specifically about functional order.
Okay, that makes sense. A constant battle. What's the second principle?
The second one is the principle of telic resonance. This is where you get synergy.
The whole being greater than the sum of its parts idea.
Exactly. Think of an orchestra. If every musician plays their own thing, it's just noise, right?
Chaos.
But when they all align with the conductor, with the score, suddenly you get this powerful, beautiful music that's telic resonance. When the individual parts, the subsystems, align their purposes with the main system goal, you get this huge amplification of effectiveness. And, interestingly, the flip side is also true. Just one really badly misaligned part, say its function, $5, is close to zero alignment. That can massively drag down the whole system's coherence.
Wow, so one bad apple really can spoil the bunch, functionally speaking.
Pretty much. It highlights how critical that integration is.
Okay, this framework of purpose as a battle and alignment creating resonance, it feels intuitive. But the big question, how do we actually put numbers on this? What are the key metrics?
Right, the measurement part. TE proposes 3 core state variables you can, in theory, quantify. First, as we mentioned, is coherence, gamma. Think of it as a score, 0 to 1.
0 to 1.
Yeah. It tells you, right now, how well integrated and aligned the system is towards its defined goal. 1 is perfect alignment, 0 is complete functional disarray.
Like a perfectly drilled team versus utter confusion.
Exactly. And crucially, it's not just calculated from physical connections. It uses something they call functional topology analysis.
Okay, what's that?
It maps out the purpose-driven network, how different functions rely on each other to achieve the overall goal, not just which wires connect where.
Interesting. So it's about the why, not just the what.
Precisely. Second variable, adaptive potential, lambda.
Lambda, right, the resilience factor.
Yeah. It measures the system's built-in capacity to reorganize, to restructure itself when things get disrupted. How well can it maintain or get back its coherence?
Like, if a supply chain route gets blocked, can the system find another way?
Perfect example. Or a biological system rerouting metabolism if a food source disappears. High lambda means it can bounce back, adapt quickly. They quantify this by looking at the structure of that functional network again, using math like topological persistence homology. It finds sort of holes or alternative pathways.
Purpose cavities, the paper called them.
Yeah, purpose cavities or redundant channels, basically signs of flexibility built into the functional structure.
Okay. Coherence gamma, adaptive potential lambda. What's the third?
The third is telic entropy, Kate Day. This is the measure of disorder, but specifically functional disorder.
So the opposite of gamma?
Essentially, yes.
Yeah.
It reflects the loss of purposeful structure, the degree of functional disorganization, how much has the system drifted from its optimal or purposeful state. Low stis is good, high stis means things are falling apart functionally.
Right. Clear desk versus total mess. Got it. Okay. Gamma, lambda, saint. This is starting to feel like a physics for purposeful systems. And then the paper mentions Telic Fields. Now that sounds fascinating, maybe a bit sci-fi. How does that fit in?
Huh. Yeah, it does sound a bit out there, but it's theoretically grounded. Remember we talked about systems as purpose-driven networks?
Yeah, based on function, not just physical links.
Right. And lambda, the adaptive potential, comes from the structure of that network.
Yeah.
Now, how does the purpose itself actually influence the system, especially across distances? That's where Telic Fields, denoted by CSI, PT-Lao, come in. The idea is inspired by field theories in physics, like gravitational or electromagnetic fields.
Okay.
But instead of gravity or magnetism, these hypothetical fields model the non-local influence of the system's overall purpose.
Non-local, so acting at a distance.
In a functional sense, yes.
Yeah.
Imagine a strong company vision. It can influence decisions of departments that don't directly interact, right? It sort of permeates the system.
I see. Like a guiding principle that's just there.
Exactly. The framework suggests these telic fields propagate through the system, influencing its coherence and, importantly, being amplified by higher coherence. So more purpose leads to a stronger field, which encourages more alignment.
A positive feedback loop for purpose.
Potentially, yes. And this offers a theoretical handle on some really puzzling long-range coordination effects we see in nature.
Like what?
Well, the classic example is in quantum biology, specifically photosynthesis in plants.
Yeah.
Energy transfer happens with remarkable, almost spooky efficiency across complex molecular structures.
Yeah, I've heard about that. It's weirdly efficient.
It is.
Yeah.
Telic fields could provide a mechanism for that kind of long-range coherence, guiding the energy transfer along the most functional pathways. It's like purpose adding an extra dimension influencing the dynamics.
Okay, that's pretty mind-bending. But let's bring it back down to earth a bit. The paper discusses some really potent-sounding hypothetical applications. How does measuring gamma, lambda, and saint actually help solve real problems?
Right, this is where the rubber meets the road, hypothetically at least. The potential comes from using gamma lambda, and not just to understand, but potentially to intervene. Let's look at biology first. Take cancer mitigation. From a TE perspective, cancer is seen as a fundamental breakdown in telic coherence.
The cells stop working for the whole organism.
Exactly. Healthy tissues have high gamma, maybe 0.8 or higher working together. Tumor cells, their gamma plummets, maybe down to 0.2, 0.4. They're functionally decoupled, pursuing their own selfish goal of proliferation.
Okay, so you can measure that difference. What then?
Well, the in silico validation computer simulations explored applying telic field interference, basically simulating an increase in telic entropy, locally, just within the tumor.
Trying to disrupt their rogue purpose?
Precisely. And the simulation suggested this could promote apoptosis, programmed cell death in the tumor cells. It hints at a new therapeutic angle, target the functional coherence of the cancer itself.
Wow. Okay, what about aging?
For aging reversal, TE frames aging primarily as a decline in adaptive potential in lambda.
Our ability to repair and adapt just fades.
Yeah, our systems become less flexible, less able to bounce back from damage or stress. So the hypothetical validation here involved simulations with C. elegans.
Those little worms labs use a lot.
That's them. They computationally boosted the connectivity and redundancy in the worm's mitochondrial networks, basically artificially increasing their calculated lambda.
Enhancing their cellular resilience.
Right. And the result in the simulation was pretty stunning, a 40% increase in average lifespan.
40%, that's huge.
It is. Now, it's simulation, but it suggests that maintaining or restoring lambda at the cellular level could be a powerful anti-aging strategy.
Okay, biology is fascinating. What about AI? That's a huge topic now.
Absolutely. AI alignment. This is maybe one of the most direct conceptual fits. How do we make sure AI goals line up with human values?
The million-dollar question, or maybe trillion-dollar.
Right. Well, TE offers a formal way to think about it. Misalignment is seen as a divergence in telic entropy between the AI and human values.
So, scatter for us versus cellular for us.
Kind of. If the difference, ST text human, gets too large, if the AI's functional disorder relative to our goals crosses some critical threshold, delta text grid, you have a problem.
So you could potentially track this divergence numerically.
That's the idea. It reframes alignment from just a philosophical issue to a quantifiable engineering challenge. Can we design AI architectures that inherently promote high coherence, high gamma, with human-centric goals baked in?
Like building alignment in from the ground up.
Exactly. The paper even proposes an ethical coherence theorem as a formal basis for designing AI that is structurally biased towards aligning with our purposes.
Okay, that's deep. Any other big examples?
One more really large-scale one: planetary engineering for climate stability.
Whoa, okay.
Think of the Earth's biosphere as one massive, complex, adaptive system. Its overarching purpose, you could argue, is maintaining planetary habitability.
Keeping things stable for life.
Right. Which requires a pretty high overall coherence, gamma, maybe above zero 0.7 on their scale. So simulations were run using what they called coherence amplifiers. Things like large-scale reforestation, restoring biodiversity, optimizing global nutrient cycles.
Things we already talk about for climate change.
Yes. But framed here as interventions designed to explicitly increase the planet's overall functional coherence, its gamma.
And what did the simulations show?
They showed that these interventions significantly reduce the simulated risk of ecosystem collapse under climate stress scenarios by 65%.
65% reduction in collapse risk just by increasing the system's coherence.
By increasing its functional integration and resilience, its gamma, and potentially its lambda, yes. It suggests a way to think about planetary stewardship in terms of managing functional coherence.
It's amazing how this single framework seems to stretch across scales, from cells to AI to the entire planet. It feels like it's trying to bridge gaps between different scientific fields.
It really is. That's a key part of its ambition. It tries to unify concepts. Take thermodynamics. We talked about entropy.
Yeah.
TE refines this with telic entropy, focusing specifically on the loss of purposeful structure, not just any structure or energy dispersal.
A more targeted view of disorder.
Right. Or control theory, which deals with stability. Lambda, the adaptive potential, kind of generalizes stability. It's not just about holding steady, but about the system's intrinsic capacity to maintain its purpose through internal reorganization and flexibility.
So stability through adaptation.
Exactly. And we already mentioned quantum biology, where Telic Fields offer a potential explanation for that weirdly efficient long-range coherence in things like photosynthesis.
So it provides potential theoretical underpinnings.
It attempts to, yes. But, and this is important, we need to talk about the challenges and, frankly, the ethical side of this.
Absolutely. With potentially powerful ideas come big questions.
Definitely. First, the practical limitations. The biggest one right now is sensor resolution for gamma measurement.
Actually measuring that coherence in real time.
Yeah. Imagine trying to map every functional dependency in a living brain, or the global economy, or even a complex ecosystem, the amount of data, the complexity. We need much more advanced measurement tech and analytical tools than we currently have for many systems.
So it's theoretically powerful, but practically very difficult for complex cases right now.
For many complex cases, yes. And then there are the ethical risks, this idea of purpose engineering. It's profound.
Yeah, the ability to potentially tweak the purpose of a system.
Who gets to define that purpose? If we're talking about ecosystems or AI or even potentially biological interventions, who decides what the goal should be?
Huge question.
And what about unintended consequences?
Yeah.
Complex systems are notorious for reacting in unexpected ways. If you start manipulating functional coherence, what else might happen?
And autonomy, especially with AI or maybe even biological systems down the line.
Big implications for autonomy. Does engineering purpose undermine agency? These are massive ethical questions that need careful thought, strict guidelines, and wide public discussion before the technology, if it develops, gets too far ahead.
So caution is definitely needed. What's next for TE then? Where does the research go?
Well, The immediate goals are likely experimental validation and simpler, more controllable systems. Maybe synthetic biology constructs, simple ecosystems, maybe certain types of computational systems.
Test it where you can actually measure things more easily.
Exactly. Also formalizing the mathematics further, developing a full telic calculus to describe how gamma, lambda, and Soc change over time and interact. And of course, developing better algorithms for gamma measurement and for optimizing lambda.
Lots of work still to do.
Oh, absolutely. It's a very nascent field.
Right. Okay, so wrapping this up. We've journeyed through Telic Engineering, this idea that functional coherence, how well things work together for a purpose, isn't just a nice thought. TE proposes it's a real, measurable, fundamental property of nature, moving purpose out of philosophy and into, well, quantitative science.
That's the core idea.
Uh-huh.
It offers this potentially universal way to look at complex adaptive systems, from disease to AI safety to planetary health. It's about understanding the dynamics of functional organization.
It really is a different lens to view the world through.
It aims to be, yeah, a lens focused on purpose itself.
And that leaves us and you listening with a pretty big thought to chew on. If we really can measure and one day maybe even engineer this functional coherence,
Yeah.
what does that mean for us? What responsibilities come with that power when we design the systems of the future, biological, artificial, social, global? What new kinds of purpose could we unlock? And maybe more importantly, what kinds could we accidentally break?
Profound questions indeed.